Good day, this is Jim Pytel from Columbia Gorge Community College, Renewable Energy Technology Program. This is ET 121, Digital 1. Today we're going to discuss implementing combinational logic using Nand gates. Okay, the easiest way to actually discuss this is with an example. And what I'm going to do is just draw out a simple circuit here using Nand gates. And there you go. You got A, B, C, D. And what's coming out here? Well, it's NAND AB. So it's A and B. Then we negate that. What's coming out here? It's C and D. And we negate that. And then what's coming out here? Well, it's the AND of not A and B. And C, excuse me, not C and D. And then it's negated. Okay? So what are we going to use here? We're going to use de Morgan's theorem. Basically, we can break this apart. And we know that a double negative will cancel AB or CD. So what we've done here is basically simplified from the two-layer NAND circuit. We've got an AND layer and an OR layer. Remember what, like I was talking about earlier in our combinational logic, is what comes first? Well, multiplication comes first. This circuit can be simplified like this. So A and B, C and D, and what's coming out here? A and B or C and D. Pretty cool, huh? So that's kind of the long way around of doing it. There's a super shortcut to do this, and that involves using, because remember our NAND can also be used as a negative OR. Okay, they're equivalent. So what you do, start at the output for, let's just say this guy again right here. There you go. So our original circuit, start at the output and have this guy become its negative OR equivalent. Okay, now there's something called pushing the bubble, and I just don't like that term because it just sounds stupid. But think about this. This bubble here, this negation bubble, and this negation bubble, if you think about it, slide it that way and slide it this way. What happens when you knot a knot? Basically, they cancel each other out. What you get here is sliding those bubbles down the rails until they cancel out. You get the equivalent. So A and B, C and D, A and B or C and D. Pretty cool, huh? So for no other reason than I think it sounds stupid, pushing the bubble. Basically, the bubbles cancel each other out. Key thing, start at the output and just alternate levels. So do a negative OR at the output, then do NAND, negative OR, NAND, negative OR, on and on and on and on. So let's draw a sample here of a bunch of NAND gates hooked together and see what we can do with it. There you go. Try this example here. So it looks like, you know, you can do it the long way and say, okay, this is A and B, negate that, and then go through all this. You know, you can do that, but here's the fast way to do it. Is go ahead and change this guy right here to a negative OR. And then keep the next one as a NAND. And then change this guy to a negative OR. And since this guy is on that same level, change him to a negative OR. Now you'll notice that here's our, I'm going to divide it up into layers. Here, actually, let's use different color. That's our output. This is the 1, 2. Okay? So it's negative OR, Nand, negative OR. Notice how it's bubble to bubble. No bubbles. And if we had another level, this would be Nand over here. That'd be level 3. And that would be bubble to bubble also. But we're not dealing with that one. We only have a 2-layer. Okay, so now, what are you going to do? Just think that the bubbles cancel each other out. Okay, so you've got here is this one is going to cancel out that one. Then this one is going to cancel out that one. That's still an OR. Okay, now what happens at this end? Well, why not just put an inverter for A and an inverter for B. Same thing for D and E. And what you get here is, this is just an easy way of getting, basically what is this mess of Nands connected together? What does it yield? Well, right here is going to be not A or not B. That's our negative OR. This right here is going to be C and not A or not B. Now let's start back over here.